Hey guys, welcome back. So far we have talked about how to balance chemical reactions. We have talked about the difference between reactants and products. And now today we are going to learn about the different types of chemical reactions. Now there are 5 different types that we have to learn about today. You guys just have to be able to look at the reactions and then be able to identify them based on what's going on. So basically just look at them and categorize them based on what we're about to learn. Okay, so that's going to be our goal for today. So this first slide here is just a little bit of a review. So remember, chemical reactions occur when bonds are formed or broken. Remember, we're having a chemical change. And then chemical reactions involve the creation of new materials, right? So we're putting something in on the left, our reactants, and we're getting something out on the right, our products. Okay? So let's just keep that in mind as we're moving forward today. So remember some evidence of a chemical reaction. We could have the release of a gas, the formation of something called a precipitate, which is a new substance. If you guys look at the bottom of the screen, that's a depiction of a precipitate there, kind of forming out of the solution. Or if you have a color change, that could also be the indication of a chemical reaction. And that is nothing new, that's just a little bit of review. Okay, so remember, our reactants go in on the left and our products come out on the right. Now, here is what I want you guys to do, because we're going to be talking about these 5 reactions you see here where it says type of reaction. We're going to talk about synthesis, decomposition, single replacement, double replacement, and combustion. So we're about to go through all 5 of those right now. Normally you guys take your notes where you just, bullet point down in your notebook, etc. But for today, what I want you to do is I want you to copy this table. Okay, so I want you to, and if you need to flip your notebook on the side, use a ruler, however it is that you want to do it, I want you to create this table. You want to leave yourself a pretty good amount of space for each of these different types of reactions so that you can fill it in. But on these next slides, you're going to see the information that needs to go in the table. Okay, so for your notes today, you're going to be copying this table into your notebook and filling it in that way. Okay, so let's talk about the first type of reaction that goes in that first row of your table. We're talking about a synthesis reaction. Now, if you synthesize something, you create something. So if you're synthesizing it, you're making something new. So this is when 2 reactants come together to form one product. So the general equation is A plus B will yield AB. So 2 elements come in, 1 compound comes out. And here we have the example, 2 sodium plus chlorine will yield 2 sodium chloride. Okay, so 2Na plus Cl will yield 2 NaCl. And of course, that's just a balanced equation, and we know how to balance those at this point. So you can tell that this is a synthesis reaction because you have 2 separate things on the left-hand side, so our reactants going in, and then we have 1 compound coming out over here. So the example here, we have Jay-Z and Beyonce. So Jay-Z and Beyonce were both single individuals, and then they got married, and now they are together a couple, right? So singles on the left, couple on the right. So Jay-Z and Beyonce would represent those single elements, and then once they got married, they became a compound. Okay, that's a synthesis equation, or reaction, I should say. Decomposition, this is when one reactant breaks down to form 2 or more products. So this is like the opposite of a synthesis reaction. So the opposite of synthesis is decomposition. And our general equation is AB will yield A plus B. So same equation as last time, except it's just pretty much going in the other direction. So 2 sodium chloride will decompose to yield 2 sodium plus chlorine gas. That's what that means right there. Okay, so here with decomposition, you're going to start with a compound on the left, and you're going to break down into 2 or more elements on the right-hand side. Okay, so we're starting off with a big compound, breaking it down into smaller compounds or elements. Now, decomposition reactions are the only reaction where you end up with more than what you started with. if that makes sense. So like we only have one compound on the left, but we have two elements on the right. So decomposition is going to be the only reaction where you end with more than what you started with. Okay, that's a question in your checkup today, so I just wanted to make sure I pointed that out. So here's our example, Kim Kardashian and Kris Humphries. If you guys remember, they were married for like 72 days, I think. They started out as a couple, and then of course Kim decided that she didn't want to live that married life anymore, at least not to Kris Humphries. So she filed for divorce and they became single. Okay, so Kris Humphries and Kim Kardashian starting off together as a couple or a compound, and then decomposing into their single selves, at least until she met Kanye. And I guess we could do this slide for her and Kanye now too, since they are now divorced. All right, single replacement. So this is our third type of reaction. This is when one element replaces another in a compound and one element ends up single. Okay, so we're doing a little bit of a switcheroo. Our general equation is A plus BC will yield AC plus B. So if you look here, we've got A plus BC, and then on the other side, so our reactants are A and BC, and on the other side we have AC plus B. So this A snuck in, bonded with this C, and then the B got left out to be single. Okay, there's only one switcheroo happening here, right? We're getting one replacement. Here's our example. We've got 2 iron plus 3 copper chloride will yield 3 copper plus 2 iron chloride. If we look here, it's the iron that's making the switch, right? So iron is replacing the copper. So it's pushing the copper out. So the iron is going to now bond with the chlorine, and then copper winds up by himself. In these replacement reactions, like will replace like. So like here we have metal. If you notice the iron is switching around, the iron is going to replace the copper because iron and copper are both metals. So like will replace like. So if you have a metal switching, it will be a metal that replaces a metal. Okay? The example here we have in the beginning, Angelina Jolie plus Brad Pitt and Jennifer Aniston. And they are... this was a long time ago, like early 2000s. Brad Pitt and Jennifer Aniston were married and Angelina Jolie was single. Then after the notorious Mr. and Mrs. Smith movie, Brad Pitt and Angelina Jolie got married, and then Jennifer Aniston was left single. So it was a single replacement. Angelina Jolie replaced Jennifer Aniston to marry Brad Pitt. Okay, so also, this is an old slideshow. Jennifer Aniston or Brad Pitt and Angelina Jolie are now divorced, but it's still a good representation of these chemical reactions. All right, so that was a single replacement. Now let's talk about a double replacement. So in a double replacement, 2 compounds trade atoms. So here we have AB plus CD will yield AC plus BD. So 2 things are switching around. So here we have calcium chloride plus silver nitrate will yield calcium nitrate plus silver chloride. Okay, so the calcium and the silver just switch places. Okay, it's very similar to a single replacement or displacement. You can see it as both. The only thing that's different here is here 2 things are switching around. And just like with our single replacement, like is going to replace like. So the metals will switch if it's a metal that's switching around, or non-metals if it's a non-metal. Okay, so here the calcium and the silver essentially just traded places, so they switched around. In the example here, we have these couples. So they start off with their own individual partner on the left-hand side, and then they essentially just switch couples, right? So like if you and your best friend were both dating like 2 different individuals, and then like halfway through your relationships, you both decided that you like each other's partner better and you switch partners, that would be a double displacement. And our last one is combustion. So combustion reactions are really fun. They can, well, I say really fun. Combustion reactions are like burning wood, burning paper. In the chemistry lab, it's like the oxidation of a gummy bear or the whoosh bottles, if you guys have ever seen that. But this is when a hydrocarbon reacts with oxygen gas to form CO2 and water, okay? The general equation, hydrocarbon plus O2 will yield CO2 plus H2O. Now, a hydrocarbon is any compound that has carbon and hydrogen bound to each other. This is going to be the fuel source, okay? Essentially, it's fuel source plus oxygen will burn, and then it will produce CO2, carbon dioxide, and water, okay? With this, it can be a little bit tricky. Look for the word burn, or always look at your reactants and your products. For your reactant, it will always be some kind of CH molecule. It will have C and H in it, plus O2. That will always be on the left-hand side. And then on the right-hand side, you'll always have CO2 plus H2O. Okay, so if you see on the left, it's CH, any kind of CH compound plus oxygen, and on the right-hand side, you see CO2 and water, it's going to be a combustion reaction. And then the example, CH4 plus 2O2 will yield CO2 plus 2H2O, and that is a balanced combustion reaction. This is why global warming happens. So remember, just throwing it back really quick to earth science, when you learn about the combustion of fossil fuels are hydrocarbons, like gasoline that we put in our cars. So every time you get in a car and you're running the engine, that's a combustion engine. CO2 is being emitted, which is a greenhouse gas, which causes global warming. Okay, so now let's do some check for understandings. Normally, when we do these, I ask you to read through them, pause, see if you can answer them, and then restart the video and just check your answers. All right, so I'm just going to put some chemical reactions up, and you're going to determine, is it synthesis, decomp, single replacement, or double replacement. So here's our first one. We have CH or C6H14 oxygen gas is going to yield 12 CO2 plus 14 H2O. Okay, pay attention to the reactants and the products. Pause and see if you can answer. All right, this is a combustion reaction. We know because we have the hydrocarbon on the left plus oxygen, so that's C6H14, that's a hydrocarbon, that's your fuel source. Oxygen gas goes in, and then CO2 and water comes out. That's how you know it's combustion, because those reactants and products will always be the same. All right, next up we have BaCO3 will yield BaO plus CO2. Pause, see if you can answer. Okay, this is going to be a decomposition reaction because we're starting with a large compound, right? And it is decomposing into two smaller compounds. So remember, decomposition, you're always going to end up with more on the right-hand side than you have on the left-hand side. So we started with 1 on the left and we ended with 2 on the right. And that's the only reaction that we're talking about today that is like that. So decomp is the only one where you wind up with more on the right than you have on the left. All right, we have phosphorus plus oxygen will yield 2P2O5. What is this? Try to pause and answer. All right, this is a synthesis reaction because we have 2 different elements on the left and 1 compound on the right. So we're making something new. We have 2 elements on the left bonding together to give us 1 compound on the right. All right, let's do 2 more. Go ahead and pause, and we'll put the answers up. All right, this first one is a single replacement reaction. So if we look here, the potassium is going to be replacing one of the hydrogens and switching around, so we just have 1 single replacement, and we're leaving hydrogen gas by himself, so that is a single replacement. And then our next one is a double replacement. So if you look, the calcium and the sodium have just switched places, so that is a double replacement. Remember, when they're both switching, basically switching places to be with the other compounds on the other side of the reaction, then you get their double replacement. Single replacement, 1 single thing is moving around. Double replacement, 2 things are switching. Okay, that's the easiest way to remember that. All right, and that's the end for today. If you guys have any questions, let me know. You're going to do a checkup. Again, with these, if you just have your table in front of you, you just